Okay. So on Monday's class, we talked about a lot of qualitative data. Today, we're going to start looking at quantitative data and how we can do some specific graphs for those. The first thing we're going to look at is how to create a frequency distribution. So like with qualitative data, when we were doing our frequency distributions, it was really simple. You would just pick the categories that was there and count up to whatever values were in it. However, if we're looking at quantitative data, like let's look at heart rates, the question is how do we organize it? If I just said everybody in here organize this data and put it in a frequency distribution, would everybody in here do it the exact same way? Majority of you probably would just do it by tens because that's the easiest way to do it. But not necessarily. You could split them up by fives. Like that's the thing. When you're looking at, there's no right way necessarily to do this. You can split it up any way you want to do. So we have to have some kind of set of rules to be able to come up with a frequency distribution so that no matter how you do it, the data is still going to end up being correct. Or the information you're going to get out of it is still going to be helpful. Okay. So when you're creating a frequency distribution, look at one briefly so we can see about what it looks like. So remember I said if we're doing it, basically most of you probably would have done it by tens. This is a sample that's done by tens. So they decided to go from 57 to 66, 67 to 76, and so on and so forth. So can anybody tell me what the lowest number of, what's the lowest heart rate in that table? Yeah. So out of the 50 students, is there a 57?
We don't know.
You do. Look at, I gave you the list of them all.
Oh.
So what's the smallest one?
62.
62 is the smallest one. So why did they choose 57? It was just arbitrary. They decided to choose 57. You could have started at 60. If you started at 60 and went to 60 to 60 to 69, would that have changed your frequency distribution? Well, the 67, 68, and 69, those values would have gone from this one to this one, right? And that would have changed those numbers. So it still would have been right. It wouldn't have been wrong. But that's part of the things that you have to look at when you're trying to create those distributions. So the first thing we want to do when we're creating a frequency distribution is we want to determine how many classes there are. So first step, how many classes? So in this one, how many classes are there? There's 5. So your classes are basically how many different bins you're putting things into. So in this case, we had 5 classes. We could have done more. We could have done less. Probably wouldn't have wanted to do less. 4 or 5 is typically about the lowest you'd want to go. And just like we saw with the pie chart example, you don't want to go too many, because then your data is going to be spread out too much, and you really aren't going to see any kind of patterns or anything else. Because the entire purpose of looking at a frequency distribution, and what we're going to go into in a little bit with histograms, is looking for patterns, looking for what you see happening with the data. So too much spreads it out too far, and you lose stuff. Too small, too little, and the same concept happens. You don't get to see what's going really on. So in this case, they chose 5. So we've chosen the number of classes we want. The next thing, which is actually the most important one, is determining our class width. So class width sounds really complicated. Really not. So class width is the smallest number, is basically how wide you want your values to be. So in this problem here, my class width was 10. Because 57 to 66, there's 10 values there. Does everybody agree that there's 10 values there? If you subtract them, what do you get? What's 66 minus 57? 9. Not a trick question. So why is the class width 10? You have to include the number you're starting with. When you subtract, you don't include the number. You're looking at the difference between the two values, not counting the numbers. So when you're counting, if you count 57 to 66, you count 10 numbers. That's where the class width comes into play. So when you're looking at doing those calculations and stuff, keep that in mind because that is a very easy mistake to make. Okay. So I've seen quite often where people go, okay, it's 57 class width of 10, 57 plus 10, and go 57 to 67. That's actually a class width of 11 if you count your numbers. So just keep that in mind when you're doing your class widths. To calculate your class width, there's actually a way to calculate it to come up with the correct value, but then we can kind of play with it. We take the maximum value minus the minimum value. So let's get the table back up here. So what's my maximum value? And what did I say my smallest value was? 62. And we wanted 5, right? Okay, so it's 98 minus 62 divided by 5, which is?
22, isn't it?
Nope.
Oh, no, 7.2.
7.2. You do not have to do this in your head, guys. Calculators are fine. Calculators are acceptable. Calculators are preferred. Okay. All right. But they used 10. So first of all, we don't want to use a decimal. Okay. So we don't want to use 7.2 because that's just going to make our lives messy, especially when all the numbers are whole numbers. We can technically use any value we want after that point. So you can use 8, 9, 10. You want to have all of them be basically the exact same width. So if you start off with, say, 10, they all should be 10. But as you saw when we looked at that, I went a lot lower than my number that I started with, and I went higher than my final number. Okay. So let's use 8 for my class width instead of 10. So we'll start off at 60. Okay, so we're going to get a little closer to that 62. So 62 what is going to be my first class? Yeah. 67. Does everybody agree with that? If my class width is 8, I'm starting at 60. I'm going to go to 67. So the easiest way to do this, the easiest way to think about this, is always add one less than what your class width is, because you're not including the number you're starting with. Okay. So since we're class width of 7, or class width of 8, I'm going to add 7. Okay. Does that make sense? Yes or no? Okay, one way or the other. You guys are all going to have to actually do this soon on your homework and on the test. And this is the basis for a lot of the other stuff that we're going to look at. So if you don't understand this, now's the time to ask about this. And there is no stupid questions. You're still learning all this, so it's fine. All right, so what's my next class going to be? So what would be the next class? What would I start off with my next number? 68. I'm not going to use the number I started with, ended with the other one. I just go one more. Okay, so 68 to what? 68 plus 7. 35. Next class? 2. 83. Next class? To what? Yeah. Next class? 2. How many classes do I have? 5 classes, which is what I wanted, right? Okay. Do I encompass all of my numbers in my data set? My lowest number was 62. My highest number was 98, right? So in my classes that I chose, I will cover all of my numbers. So this is an acceptable class. These are acceptable classes. Okay. Now all you would do is go through the table and count how many are in each class. So what I would suggest to do when you're doing this is don't sit there and go, okay, 60s and go through the whole list. Start at the beginning and just do tally marks and then count up your tally marks at the end. Because the odds are, if you're looking for, okay, 60, so that one, you're going to miss one. It's inevitable, especially when the lists are a little bit long. So to start at the top, make tally marks and count them all up. So 77, 60, or 84, 79, and just keep going till you get all 50 of them. Go ahead. And no, I don't have the answer yet because the book did it with 10s and I'm making you do it with 8s. So I'm literally doing it at the same time as you are. All right. We're almost done. All right. How many in 60 to 67? 68 to 75. 76 to 83.
26.
84 to 91.
10.
92 to 99.
3.
3. I was gonna say this is wrong. I'm gonna assume that's wrong. What'd you get for the middle one?
I had 27.
26.
All right. There's 50 numbers. So 6, 15, 25. I have 25 left.
All right.
Maybe I missed one somewhere, but
I do think I counted one extra by accident.
I had 27 in that one and then 8 and the other one added up to 50.
Yes, that would add up to 50. Okay. I've got 20 something of you in this classroom. Everybody agree with 3? Everybody agree with 9? Everybody agree with the 3 at the end? So it's these two that are the question? Okay. How many have 10? How many have 8? How many have 9? How many didn't do it? Ay, 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 ay. All right. I'm gonna have my class do the homework. All right. So what'd you have? 24 and 20, or 27 and 8?
Yep.
All right, we're gonna go with you. If you're the only one that seems to have both there, we'll go with that. It's fine. Not the end of the world. It's off by 1. Okay. So is this the same as this? No. Because they looked at different classes, right? So that is going to make a difference in how your chart comes out. Is the pattern the same though? So if you look at it, it's kind of going up, up, and then back down, right? So same kind of pattern with it that are there. And that's the one thing you really want to look at when you're looking at your frequency tables is what's that pattern look like? Yes.
Still a little confused about the class with.
So when we calculated the class width, you got a 7.2 using the formula for class width, which was just the maximum value minus the value divided by however many classes you want. So at that point, you can choose what you want your class width to be. Okay. It's just got to be like, you don't want to pick something like if it was my class was 7.2, you don't want to pick like 20. Okay. Because you're either going to have to go really, really low at the end or really high at the beginning or really high at the end. Like you're going to have that split thing. And then in the middle, you're not going to really see much. You want to try to stay close to that. 10 is just an easy class width to use, and it is used quite often. So that's why the book went with 10. I chose a different one because I wanted you to see the differences there. The only thing that mine changed compared to theirs was my endpoints, the 60 and the 99, were closer to my actual data values. So they had a little bit more on the beginning and the end. So no problem. All right. So we have our class width. We found so actually we did all this already. I will show you officially and put it in the notes. We found our class limits. That's the lower class and the upper class limit, so 60 to 67. Those are those limits. And then we determine the frequency of each class. That's how you create a frequency table. Okay. Does that make sense? Yes.
Quick question.
That's fine.
So like, what you're saying by adding, just like, the difference is because you're not counting, so if I wanted to count the class, like, I would just do like one, like 60.
Yes.
Or 60, 55, 56, 57.
Correct. And you get 8. Yep. Or you can subtract them and just add 1. It's always going to be 1 more than the difference. It's always going to be 1 more than the difference, no matter what you do. So if you wanted to subtract them and add 1, you can, or count them just like that. And that will actually absolutely give you the class width. And they should be relatively small unless you have like really large numbers. The class widths are going to be easily manageable. Yeah.
I don't know if you said this, but where did the 5 come from?
We chose that. That's an arbitrary number that you chose. And we just chose 5 for this case. So I just chose 5 because they chose 5, but you could have picked any number you wanted there. So I think this actually comes out to be 36, right?
Yeah, very good.
Yeah. So you actually could have, if you chose 6 as your class width or class, your class width could have been exactly 6. And you'd have started off at 62 and you would have ended up at 98 and you would have had 6 classes in there. That is a possibility as well. Something bigger than 4, 5 is typically, it literally depends on how much data you have and how spread out your data is. Because again, you're looking for, and my screen's going to go black in a second. You're looking for the all right. Since we're not totally sure on that one, we're going to go back to the original data table that they used to do the next steps because I know the answers to those. All right, so we had our frequency table. What was the other thing that we did on Monday's class with our frequencies? We did something else with them. Or there was another table that we kind of looked at. Our bar charts were our frequency tables, right? What was the other one? Yeah. Yeah. So the pie charts fixed for they were the relative frequency tables. So we had to basically change them to percentages. So our relative frequency is the same thing as what we just talked about. All you're going to do is you're going to take each of the amounts and divide them by the total. So my relative frequency in that first class was 2. So 2 divided by 50, 0.04. Then 10 divided by 50, 0.20. So now I have my relative frequency there. Okay. Any questions with the relative frequency? It's just how many you had divided by that total amount. All right, there is 2 others, which are really quite simple to do. The next one is a cumulative frequency table. Which is literally just the sum as you're counting up. So cumulative frequency for the first one would be 2. The second one would be 12 because it's 2 plus 10. The next one would be 44 because it's 2 plus 10 plus 32. You're just basically summing as you go up. And your final class should be the total number of values that you had, which in this case was 50. Anybody want to take a guess on the other frequency table that you're going to have? Huh? Let's see. We have cumulative frequency, so we're going to have cumulative relative frequency. Just adding up the percentages. Which is your cumulative relative frequency always add to? Right. Or 1 in this case, because they're keeping them as decimals. But yes, it should always add to 1. Yes. Absolutely. There you go. All right. Any questions with creating a frequency table? Good. You're done with section 3.3. Like, wait, what? That's it? Yes. Nope, no more questions. We're done. No, I'm just kidding. What's your question?
Is that just showing like the minimal like amount of frequency like
Classes?
Yeah.
Yes.
Okay. I see.
Yeah. So if we were to do a class with a 6 for this one, you would either not cover enough information. So let's say we did a class with a 6. So if we start off at 62, we'd go to 67, 68 to 73. Yeah. 74 to 79, 80 to 85, and 86 to 92. That's 5 classes, right? And I did a class with a 6. What's the problem? Right. I don't cover all the values. I'd have to add in the next one to cover all the values. And now I have 6 classes instead of 5. So if you go lower than that number, you're always going to end up increasing your classes, which you wanted to stick to that number. But if you go higher, you're just basically adding a little on the ends, which is fine. So there's no way to do a class with a 7.2 because our values aren't 7.2s. There's no decimals in there. So they're still going to fall in those places anyway. So that makes sense? Okay. All right. Any other questions? Sure. No, you're fine. I knew you guys had questions. None of you wanted to ask. It's like I could give you another data set, make you count them all and do it out. It's just rote at this point. It's like it's just you're going to do the exact same thing we just did. So it's more of the question: do you understand how they're coming up with the classes and the class width? That's the piece that's the most important part. Like that's the piece that you need to understand. So actually, let me just have you guys do that, and then we won't worry about counting. Okay. just want. Just want the damn. All right, here. Okay. I want to do six classes. Yes.
This be considered continuous or discrete?
These are heights. These would be continuous. Heart rates are discrete because you can't have a half a heartbeat. In this type of data, it doesn't actually, you still can do all the stuff that we're doing, even if it's discrete or continuous. That doesn't make a difference. Okay, so I want six classes. Find my class rate. Six classes. So for your class, what we got to do? What two things? We need what two things? The maximum value or the minimum value? What's the maximum value? What's the minimum value? Yeah,
In, I think, the third row?
it's 55.2 is right there. And 71.6 is right there. Those are the smallest and biggest ones that I found. So we're going to take that and we're dividing it by 6. So if I remembered right, I got 16.4 divided by 6, which is 2.73333. Keep going. Yes.
Is there any way to like avoid human error with this kind of thing? Because I feel like the only way to find the highest and the lowest number.
Unless it's on a computer, then no. That literally is the only way to find it. Unless they give you the data in numerical order, that's what you're going to end up doing. So, but let's say you screwed up. Okay. Let's say instead of, we didn't see the 55 and my smallest one that I found was 58. Okay. So if I had done 71.6 minus the 58 instead. and then divided that by 6, we'd end up being 2.2. Remember, we always want to go up. We're still going to do 3. So in that respect, it wouldn't have made that big of a difference. The only thing that could end up happening when you're doing it is when you make your classes and you actually go through and do your tally marks for it, you'll end up finding a value that doesn't fit. And you're like, oh, I screwed up somewhere. And then you have to go back and fix it. This is where programs kind of help. Rugio actually does do this, but you physically then have to type all the numbers into it to get it. So it doesn't make much. It's like not like there's an easy way to just copy all the numbers over into the programs to do it. You still have to physically type them out. So unfortunately, no, there's no real easy way to do it that way. That's actually what I did when I was in there, like, oh, I'll do this one. I typed it in, got all the things, and then the program that I used made a different histogram than I had. And I'm like, that's not helping me very much. So, all right. So I got 2.7. What's going to be my class width? Yeah, I'd use 3. Technically, because they're decimals, you could have done 2.8 if you really wanted to, because you have decimal numbers here. I wouldn't. I would still have done 3. All right. So where do we want to start? Yeah, let's start at 55. So 55 to 57, 58, 61 to 63, 64 to 66, 67 to 69. It's 4, 5. I want 6 classes, and then 70 to 72. And those are my classes. And then you count all the 100, then you do the tally marks for the 100 ones, and you get into the boxes, and you can create your thing. But that's going to include all the possible values. And notice it's really close in terms of like which values I'm using, because like my highest number was 71.6 and 55.2, so it's right to the edges there, which makes sense. What was the question?
Well, are you using 3 or 2?
So remember, so if you count 55 to 57, how many numbers you get?
3.
55, 56, 57, right? So my class was a 3. Right. You always are adding 2. You add 2 because you're not including the first number. So like the bottom one, 70, 71, 72.
Oh.
So that's why I was making a statement before. It's really easy to screw that up because we always will sit there and quickly do the subtraction in our head and go, wait, it's 2, not 3. And because we're forgetting about that other one. So when you're looking at it, you either physically count it or you take one away and add that. So I always just take one away and add that because it makes it easier for me to do the calculations. And then since you're always going up by 1 to the next one anyway, that's really where that other one comes from. So does it make sense?
Yeah.
Okay. Yes.
So, well, first one on there, top left one, I know that isn't being kept first, but that's 63.8.
Yep.
We have 63 and 64.
Correct. So technically, the way this data goes, I would want to put, hold on, I need my pen. That's it. I would want to put a 0.9 on all these.
Oh, okay.
So I would include it in that one previously because these have decimals in them, so we kind of have to include that decimal piece in there. That's why I said technically you could have used 2.8 as your class width. We did not have to go to 3 and make it a whole number. We're going to talk about how to deal with that in a second. So when you're making a frequency table, that's one way that you'd actually deal with it. You typically do want to make sure you include numbers. So I would have done 0.9 in all those. It doesn't change my class width. It just, I would include it in the previous classes. So the next thing we're looking at though is, well, just like we did with the qualitative, we looked at how to create them and then we looked at graphs. Now we're going to look at graphs. So let's see, I have it here. This. What type of graph is this? Okay. Almost. Yes.
I look like I'm cheating.
Yes, it does say histogram above it. But a histogram and a bar graph are very, very similar. Okay. What is the, looking at this bar graph, what makes this bar graph different than the bar graphs we looked at on Monday?
It, like, I guess the bar kind of measures it, but it also shows by like the width kind of.
Actually, the width doesn't show anything, believe it or not. Yeah. Yes.
Shows a range of values instead of a single value.
Yes, it does show a range of values except for specific values. So typically underneath the bars that we had before, we had that we had a number or a word or whatever it was, like red, green, blue, whatever, and then we had the counts, right? So this does show a range. I can make them skinnier or longer. That doesn't matter. It's the range that matters in that respect. What's another? There's one other really big difference between this and all the bar graphs we looked at the other day. Would you like to see a bar graph from the other day?
If it's thorough connected.
Yes. That is the absolute biggest difference. These touch. Your bars and your bar graph do not touch. Because remember that whole thing we talked about at the very, one of the things we talked about at the beginning of class with connecting the dots? If there's no information between the dots, you shouldn't connect the dots. Same concept in this. If the bars are touching, that means there's some connection or relationship between those bars. In a bar graph, they typically aren't connected because there is no relationship. In a histogram, there is a relationship. That class goes from 66.5 to 66.5. The next class starts at 66.5 and goes to 76.5. Okay? So if you notice this, if we're looking at this, get the other one back. This is the bar graph for this frequency table. Notice that my classes on my frequency table are 57 to 66. The classes on my histogram is 56.5 to 66.5. That's because of what you were talking about in the last problem when we had those decimals. We still have to include those. So because I want to make sure that my bars touch, and I want to make sure that the things actually fall into only one of them, I can't make it 57 to 67, because then where does the 67 go? First bar or the second bar? So by doing 56.5 to 66.5, those values are not included in my classes. Those values don't exist in the ones. So therefore, I would know where they fall. In the last example where we did it the heights, I would have gone out 2 decimal places. Okay, I would have done 56.05 or 50, or I would have gone out an extra place. So therefore, I still wouldn't have had the values fall into place because it was 0.2 or 0.3 or 0.4. Okay, so you always want to go one more decimal place than what they gave you in the problem. And the middle should be between the two classes. Does that make sense? You're allowed to say no if I say ask, if it makes sense. That is a completely reasonable response sometimes. All right, so we've got our table. We've got our, hold on, back to my thing. I'm just trying to find the next piece, the official definition, because I know some of you guys really like the definitions. This is the official definition of a histogram. So you have to have the frequency table. Once you get the frequency table, you can make a histogram. The nice thing about a histogram is it starts to give you that shape. You can start to see patterns forming in it. Just like we were talking about before, picture's worth 1,000 words. Sometimes that picture will help you recognize a pattern more than just the numbers will. Okay. All right. Here's a bunch of histograms. So, again, there's no actual data on these on purpose because it doesn't really make a difference. We're looking at just in terms of what the shapes and stuff are. So histograms can come in a variety of different signs or designs and shapes. It doesn't make much difference. It depends on what the data is. But depending on what the data is, depends on what we can do with it. And depends on what information we can get out of it. Most data that you're going to look at is going to fall something looking like that first one. Anybody seen a shape like that before? A parabola. It's actually a bell curve. It's actually considered called a bell curve in statistics. So that's your bell curve. Your bell curve has flat sides and things. It's pretty much symmetrical, and it has that dome shape in the middle. Okay. If a teacher has ever told you they grade on a bell curve, run away from that class as fast as possible, because somebody's failing, and only one person's getting an A. Because that's a true bell curve. We'll understand that later in the class on why that's true. So it's pretty much symmetrical, and it's got that curve too. Then we have the other two on the top. We have a skewed left and a skewed right. I'd like you to look at those two, and do those two, the names of them make sense? Okay, very good. That's exactly what I wanted you to recognize. You're not telling me where the bar is. You're telling me what's pulling it. So the skewed left and the skewed right is where the tails are. Okay. So if we look at this one here, so this one's got that nice bell curve shape. This one's got that shape like that. And this one's got that shape like that. So you're looking at these parts here. Okay. So the tails are going to tell you which direction it is being pulled. So skewed left, the tail's pulling it to the left. Skewed right, the tail's pulling it to the right. I do not know why they talk about this now, because there's no other context that I can give you at this point without doing a bunch of other calculations. But I know it happens to show up in your homework, so I need to talk about it. So it's opposite of the way you would think, because you're not telling me where the hump is, you're telling me where the tail is. That makes sense? Write that down in your notes, because you're going to forget about it the next time you see those words, and you're going to assume it's the other direction. All right. The other three are ones there. They're probably not going to show necessarily up on your homework. But you can see uniform is pretty much the same all the way across. There's some dips and divots there, but it's pretty much the same. Bimodal, you have 2 humps. Multimodal, you have more than 2 humps. So, but these are the ones that you're going to see most often. Are the bell shape and then skewed left and skewed right. Okay. Any questions on that? Okay. All right. Hold on. I don't want the whole thing. I just want this. Okay. Anybody seen this before? This is known as a stem and leaf plot. This is looking at the exact same data that we looked at before. This is still the heart rates. Okay. The stem and leaf plot is actually very similar to a histogram. It always uses a class width of 10 because it's breaking it down into the actual numbers that we normally think of. So it is grouping by tens. So the first stem is 6, which stands for the 60s. So the numbers that fell into that one would be 67, 69, 68, 65, and 62. That's what a stem and leaf is. That's the stem. That's the leaf. You put them together to get the actual numbers. That's actually all a stem and leaf plot is. The nice thing about a stem and leaf plot is it is the only graph. It is the only graph that actually keeps the values there. Okay. So in a histogram, you don't see the data points. You just see a bar. You know how tall the bar is. You know how many data points are between those two values, but you don't know what the actual values are. If I took this and made this a bar graph, I'd have 1, 2, 3, 4, 5 there. 16 there. 4 there. And 25 there. That would be my bars. I'd go up 5, I'd go up 16, I'd go up 25, I'd go up 4. But I'd only see the bars. The stem and leaf plot allows me to do both. Okay. Also notice that it's kind of like you did with the tally marks. You're just writing the numbers down instead of a mark. So you almost make your stem and leaf plot and your histogram all at the same time. The downside to a stem and leaf plot is it only works with groups of 10. Okay. So if I had a number that was, say I wanted to graph the number 115, I would have 10 and I'd have nothing next to it. And then I'd have 11 and I'd have a 5 here. Because that's 115. Okay. And if I had another point of 118, I'd have the 8 there. That'd be 118. So the stem and leaf plot only works with groups of 10, and it's based on our number system. So it's the 60s, the 70s, the 80s, and so on and so forth. So you can't have a breakdown like we did with the class tables where it was 62 to 68, for example, or 62 to 67, things like that. Does that make sense? Understand how the stem and leaf plot works? Okay. The one thing that you typically want to do when you create a stem and leaf plot, although you don't have to, the one you're looking at right now is based on the actual data that's there. Don't worry, when I send the notes later, they'll all be back there because I'm going to do them back for my next class. You also sometimes, and it's nice to put them in order. Because now you can see what the lowest one is, what the highest one is quite easily. You're going to be able to find middle numbers. You can find the number that appeared most often, those type of things. We start to do more of those calculations in chapter 4. We also can have a stem and leaf plot that looks like this. These are known as back-to-back stem and leaf plots, or side to side. Your stem is in the middle, your leaves come off each side. So by looking at this, we can compare data and see where there's gaps and there's information and stuff like that. So this is looking at Barry Bonds versus Babe Ruth. So if you like baseball, you know that Babe Ruth had the home run record. Now Barry Bonds has the home run record. At one point, Hank Aaron had the home run record in between there. Actually, no, Hank Aaron never had the single season home run record. But if you look at Barry Bonds' home run season of 73, what do you notice about that as compared to what you see on the other side with Ruth? That one, he has nothing because he never hit 70 home runs, but there's also nothing 10 here. His 73 season was like an outlier. It was like way above wherever he was, where Ruth had a lot of other, like had some more games in there. So it was progressively higher where Bonds was, wow, I had an amazing season. So I only show this to show you the back-to-back. Yes.
Also, the very first one for 0, there's a 0 on Ruth's side. Is that 0-0?
Yes, because he had a season with no home runs.
Oh. So then Bonds went one season while Ruth did.
So Bonds had a season of no home runs, 4 home runs, 3 home runs, 2 home runs, and 6 home runs. Because it'd be 0-4, 0-3, 0-2, 0-6. Barry Bonds had one season where he hit less than 10 home runs, basically. He had to find. Home run hit out of the park. Hard to do typically. Yeah, so these are, so like this one right here, like that's 11, right? Because it's 1-1. This one would be 0-0, 0-4, 0-3, and so on and so forth.
Is it one season?
Yeah. Yeah. No. So these are all their seasons. So each one of those is one season. So Babe Ruth hit 11 home runs in 1 year. Barry Bonds hit 16 home runs in 1 year. He hit 19 home runs in 1 year. You have to know a little bit about baseball to understand that part. That's fine. The big reason I showed you this one had nothing to do with baseball. It was more of, since you can see different ways to be able to look at some. Sometimes you want to compare different things. Like we've been looking at heart rates for one example in that breakdown. That was the number of heart rates for a bunch of different students. You could easily take your heart rates for like a month and compare them to your sister's heart rates for a month and see if they're similar. Or if your sister had a higher heart rate or whatnot there. So you can easily do this back-to-back setup and see, compare yours and your sister's heart rates for a month type deal. That makes sense? So that's why we'd want to look at a graph similar like this. You want to take a guess what this is? Yes. Nope, this isn't boxer whiskers. There's no kitty on this one yet. Oh, come on, take a guess. Yes.
Could be wrong. I was gonna say scatter. Hold on.
So a scatter plot, you need an X and a Y chord, X and Y to get your scatter plots. It is literally a dot graph. It's a dot plot. Every one of those dots is one piece of data. So in a stem and leaf plot, we grouped them by tens. Okay, so we grouped them by tens and organized them out. So my class width was 10 in that respect. When we're looking at our histogram, we can make our class width whatever we want. A dot plot, your class width is 1. Okay, every one of those dots represents one piece of data, and it's where it is located on that chart. So in this case, Chicago won 65 games one season. They won 77 games 2 seasons. They won 86 games 2 seasons. Like that, each one is one dot. Okay, does that make sense? Really straight. So you can start to see how these are all basically the same type of thing. It just depends on what their class widths are and how you display that information. Correct. You can literally count up how many dots. So there is no y-axis in a dot plot. Good observation. I don't really care about that one. We've actually seen that one before. All right. All right. So, what's a class with? Yes. Beginning and the end of where you're counting. The class width of a stem and leaf plot is always 10. Okay. How many classes you have is completely arbitrary. You can choose those. And a stem and leaf plot, it'll be specifically based on however many numbers you have, because you might have to add up extra pieces there. Other than that, that's it. We're done with chapter 3. You are going to, most of the stuff that we're going to be looking at going forward is quantitative data. Okay, we're going to be doing calculations with them all. We are going to be looking at some stuff that deals with histograms and things like that. We will do not as much with stem and leaf plots, histograms quite often. That's going to be the one graph that we'll use quite a bit. So, all right. Finish your homework.